So today's problem would be given a number in the form of a list of digits, return all possible permutations. Given a number in the form of a list of digits, okay, return all the following possible permutations. Okay, okay, so we have been given a set of numbers. We're supposed to just return the permutations. Seems easy. So copy the question. Now first, we need to figure out how to return the set of permutations when we have been given a set of numbers. So how do we go about doing it? So let's say that we have been given 1, 2, 3. So if we were supposed to find the total number of permutations for n numbers, then the mathematical formula would be like we would have n factorial number of permutations, right? So in this case it would be 1 2 3 is one permutation. Let's say if we were to do it via tree, right, that kind of makes sense. So let's say that first step we take 1, so let's say 1, we take 1, then we take 2, then we take 3, right? So basically that would be something like this would be one permutation. Then we would go back one step and say that can I replace anything else in the 2? No. So I would go back another step. So from here I'll go back here 1. I can't swap anything, but it is possible to swap 2, right? So I would say that okay, at 2's position we can have 3. So I would say you can have 3, then you can have 2, right? Keeping 1 as constant over here. So that would be the way I can find a permutation. So I have 1 2 3 and 1 3 2. So let's say we have a result of permutations over here. So we have 1 2 and 3. Okay, so this is permutation 1. Keeping 1 constant, we are going to swap out 2 and 3 in their positions, so it will become 1 3 and 2. So now 1 had been constant all this while. So next step is we need to swap the next position, right? So we'll go with 2 in this case. Starting position would be 2, right? So we'll go with 2. If you go with 2, you can have 1 in the second position, 3 in the third position. This is just arbitrarily choosing. So you can have 1 which can be having 3 as the node, right? Okay, so you can have this. So this is one more permutation, or you can have another permutation where you have 3 over here and you have 1 over here. So let's go for that. You can have 3 or 1. So this is just by swapping the positions, by keeping 2 constant but swapping other elements in the remaining of the array, right? So that would mean we get 2 more. So that would make 2 1 and 3, following which we get 2 3 1 also, no, the 2 3 1. Okay, then we can swap out 3 in the first position, right? So we say that we keep 3 over here, or kind of should be in red. So we keep 3, then I'm going to say that in 3's place I'm going to have 2 nodes. Initially I can have 1 over here and then 2, correct? 1 and 2. How we are going with this is we are just swapping the elements, and in the second place we can have 2 or 1 also, correct? So with that approach we can say that we have arrived at the set of permutations, right? So there is 1 2 3 4 5 6 6 n factorial. 3 factorial is 6 only. Okay, so our result set would now include 3 1 2 3 1 2, and then 3 2 1 also, right? So 3 2 1. Okay, so how do we do it programmatically is, initially we keep one constant in its place, right? We're going to keep it constant. Then we are going to swap around remaining digits, whatever else is there in this array, right? The source array, we'll call our source array something like in yellow. So we have source array, we have 1 2 and 3. So in this we are going to keep one constant initially. For the first step, when we are iterating over it, we are going to say, hey yo, we are going to keep one constant. Okay, iterate over the array. When we go through it, 2 initially will be in its position, that's why we have 2 over here, and 3 will also be in its position. Then we will swap 2 and 3, keeping one constant, right? So we'll have 1 2 3 will be one iteration, and in the next one we would swap out 3 and 2. This would go up to n number, like if there are n digits inside the array, we would go n times, right? So we would keep swapping out each one of those positions. Similarly, we would go to position 2, that is in the first place we would say that 1 is no longer fixed over there. We would swap 1 and 2. So in that case 2 would be in the beginning, then we would go with 2 1 3 by swapping out the remaining 2 digits. Then 2 3 1 also is possible, right? If this was a 4-digit array, this would still work, like only the number of iterations would be more. But by keeping one position fixed and swapping out the rest of the elements, we would be arriving at all the permutations that are possible, right? Like by just swapping them with the neighboring, we keep doing that till we hit the end of the array, right? Okay, so with this logic, let's try to write the code for it. Okay, and now we have a function called as return all possible permutations. Okay, diff permutate, we call some function like that, right? That takes in our source. This would be our source array, right? So we'll say source, it takes in the source, and supposed to return back the list of array, that is the permutations. Oh, sorry. We would return permutations. Permutations would be equal to an array initially, which should contain all of the numbers that they are providing here in permutations. So for doing that, first we would okay, we can have another function internally which we can call recursive, because we are supposed to keep adding to this, right? Or we can, yeah. So what we will do is we will have a function called as we'll call it as helper, just for ease. Okay, so in this logic we kept one specific index as constant, and then we kept swapping, right? So in that case we need to keep track of what is the current index that we are what do you say, keeping it as constant, from which we will proceed with the swapping. So we will say that I will have an index variable which keeps track of the swapping position, following which we would have our source array. So we'll call it again source. Then we would have do we need anything else? Do we need an ending? No, we can always get the ending from the length of the source itself. So we have this function helper, inside which step 1 is what we are going to say is if I index, if index is equal to the length of the array, right? That means length of source, right? So if it is equal to the length of source, minus 1, it should be, right? Because index is starting 0. Okay, fine. If index is equal to length of the source, that means that we have come till the last position, like we have come till the index where it is the last one, like we can't proceed further because we are hit the end of the array, right? So in that case we would say that permutations dot append, we would append the source itself, like after swapping, because we are doing all of the swapping in place, the source array itself would be what we would keep. But because lists are mutable, we need a copy of it. We can do dot copy or just do a full slice, right? So this would append the entire array back into our permutations, which would then contain at each permutation should go in over here, right? And then else, that means that if index is not that position, that is the ending position, in that case it is expected that we swap the digits, like we proceed with, let's say I index was 1 and the length was 3, sorry 2. We are supposed to keep index constant and then continue swapping from then on, right? So what we would do is, for this we would say swapping it. How do we, okay, we can swap in Python, we can just swap it something like yes, I think we can just swap using index locations itself. Okay, we'll come to that. So first we need to say that for my position in range of index, right? Does it make sense? Yeah, index up to, go till the length of the array, right? Length of my source array, correct? Okay, why are we iterating over that? Because index indicates at from which point onwards we are supposed to continue swapping, and till which point, because that would be the length of the source. So whenever we go to that position, initially this will be 0, right? Like when we start for the first time, it will be 0. So we are going to say that swap at the position. How to swap it now? Source at I, right? That is position here. This should be swapped with source index, right? I'm going to swap. Oh, sorry, it should be index and position, because those are what getting, I think it should not matter, but okay. So we're going to say that swap everything at index and position with whatever is at position and index, right? Basically it's something like source of position and index, right? That makes sense, right? At source at index. So what this would do is, initially when it was okay, we'll address that once again. Okay, we swap it, then we need to call our helper function once again, which says that, hey, go back, recursively go back and check whether you can swap more digits. So we are going back the stack over here. So we are going to say helper, this time, since first index is already kept constant, so go up 1, go to the next step, and once you go to the next step, you can take the index is that, this is the source, and then do we need the ending? No, there is no ending. So right, so what this one, when it gets called, initially index is at 0, so 0 gets fixed, and then we could do the swapping, then we are incrementing it to 1, 0 plus 1, so 1. When this array, this function is called with index 1, it would have it will check whether 1 is equal to the length of the source, that is 2, no, then it comes here for position in range. So again it swaps whatever is at position 1, right? For range, yeah, it will swap at position 1 and 2, it will swap it with 2 and 1, and then it will call helper with 2. When it goes to 2, it checks whether this length is equal. If it is equal, then it would print, I mean it would append it to the permutations. That makes sense. So it would add it back to the permutations array. But every time we swap, we need to reswap it, right? Like after the recursion is called, so that it's put back in its place over here. So for that, I think we just can directly just copy this and paste it back over here. That makes sense. So after you swap some elements, reswap it and come back, so that when you go to the next position in the swap, the previously swapped are reversed. That makes sense, correct? Yep. Okay, so I think this should ideally do it. So if that's the case, commutate. Here we can just call helper, call it with index 0, and then you pass the source. And in our main function, if name equal to main, in that case, call the function print permutations. We get permutations is equal to permutate, okay, or we can call calculate permutations or something, doesn't matter the function name. And source should be our source string, right? So we call it as source is equal to 1, 2 and 3. Save that, and now let's check source, right? Can make this a little bit better. Calculated. Okay, fine. So now if we were to run python space problem 1128. Okay, so what is expected at the first time when it calculates the permutations? One is fixed in its position. It goes down to 2 3. Then it swaps it back after it calculates that and comes back to and swaps second position, that is it goes to 2 and tries to swap it back with 2 and 3. So we get 1 fixed, 2 3 and 3 2. In the next iteration, first position itself is swapped, so we get 2 1, right? And 3 remain constant over here. Then we swapped with 1 and 2 because again we are iterating through the index, so we get 3 1. And for the third time it swapped with the third index, so we get 2 and 1, which is then swapped back with 1 and 2. So wait, do we have 6? 1 2 3 4 5 6. We have 6 permutations as expected from the question. So I think this solves this question. Yeah. Okay, thank you.